today, 1.3, we are solving equations. This time, though, there's going to be variables on both sides. So the steps still apply that you guys wrote down yesterday, but there's going to be one other big thing I need you to make sure you do. So here's the general rule when there are variables on both sides. And I want you to write it nice and big. Oops, let me pick a color. Get all variables on one side of the equation and all constants on the other. Okay, so basically the examples are going to have variables on the left and variables on the right, and your goal is going to put all the variables on one side and then all of the constants on the other side of it. Okay, so like all variables on the left and all numbers on the right. Okay, example 1. 5x plus 2 equals 2x plus 14. Oh my gosh. There's a 5x on the left and a 2x on the right. Let's start freaking out. Just kidding. So here's the biggest thing. I have 5 x's on the left and 2 x's on the right. I want to get all the x's on one side. I usually move the smaller one. So what, between the 5x and the 2x, which one is smaller? 2x. The reason why I move the smaller one is because it keeps my x's positive. If you move the bigger one, in the end, you end up with the exact same answer. Okay? So this is a positive 2x. So to move it to the other side, we subtract it from both sides. Yeah, because 2x minus 2x gives me 0. But whatever you do to one side, you have to do to the other. So 5x minus 2x leaves me with 3x plus 2 equals 14. And then we want to get all the constants, or the numbers, onto the other side. So how would I move that? Yep. It's exactly like solving now. I mean, it's always been solving, but... Okay, and then divide both sides by 3. So we end up with x equals 4. Now, just as a warning, it could possibly come out as a fraction. So if your answer comes out as a fraction, it's okay. Just make sure it's reduced. Okay? Okay, so on page 21 in your book, for problem 1, just do part A for me. Please show all your work. So for your example, 7k plus 2 equals 4k minus 10. What did you do first? Who's in 25? Brianna. What did you do first? Good. Did anybody subtract 7k instead? No. Okay, you could have. You would end up with negative 3k. In the end, it will all come out the same. You'll just end up reducing the negative. Okay, so that gives me 3k plus 2 equals what? Perfect, negative 10. Then what did you do? Is anybody in 38? Okay, 14. Alice, what'd you do?
Okay, I subtracted 2 on both sides.
Okay, and everybody, really quick, negative 10 minus 2 gives me what?
Negative 12.
Perfect.
Oh, I did subtract
Negative 12. Okay. And then, what did you do last? Who's 33? What did you do last? Divided by 3. So, everybody, we should have got k equals negative 4.
I did it the other way.
So, example 2. I'm going to just put it right next to it. Example 2 is a word problem. You do not need to write out the whole word problem, but do write down what I do so that you have just the important information, okay? So we have graphic designer or a web designer who currently, with his current computer software, can design a web page in 1.5 hours. So currently, so currently he can do one page in 1.5 hours. Okay? Now that means like when you go to a website and you click on things and it takes you to different pages, each one of those is a separate page. So he can only do one page in 1.5 hours. He buys new software, which allows him to create a page in 1.25 hours. So with his new software, he can do one page in 1.25 hours. But it's going to take him 8 hours up front to learn how to use the software. So plus 8 hours, right? Okay. I want to know how many pages can he design where it will start becoming faster the new way than his original software. Okay, so how many pages can he design before the new software becomes faster than the old software? So we want to look and see where it will take them the exact same amount. Okay, how many pages? So that means that our variable is going to be P, my last class did W, it doesn't matter. Let's let P equal the number of pages. Okay. So P is going to be the number of web pages. Okay. So how long will it take him how many web pages can he design using his old software? Or how long will it take him? 1.5 times the number of pages, right? Because it's 1.5 per page. We want to find out when that will be equal to his new software. So when are they equal? So what would we do for the new software? 1.25 P plus 8, right? Because the 8 is just 8 up front. So it doesn't have anything to do with how many pages. Okay, you have two options here. You could get rid of the decimals if you want by multiplying by 100, right? But 1.5 and 0.25, can we work with that? Yeah. Okay, so let's do that. So what's smaller, 1.5 or 1.25? Okay, so subtract 1.25p from both sides. And that's going to leave me with just 0.25p equals 8. And then what do I do? Divide by 0.25.
32.
So you get P equals 32 what?
32 hours.
No.
Pages per hour.
P is what? The number of web pages. So P is 32 web pages.
Wait, isn't it 30? His 33rd page would be faster?
So then his 33rd page is when it starts getting faster. So let's interpret what this answer means. This is saying that after 32 pages, the new software becomes faster. 32 pages is where the old software and the new software takes the same amount of time. So if this was your job, was designing web pages, would the new software be worth it?
Yeah, because if it's your job, you do it every day.
If it's your job, you're doing it every day. So he's designing way more than just 32 pages, right?
Yeah.
So let's say you own a small business and you are just making a website for your one business and you're only going to make a website once. Would new software be worth it for you?
Nope.
No. Probably not. Okay? So how did we get 32? Remember, 1.5p was how long it takes him using his old software, right? 1.5 hours times the number of pages. The new software is 1.25p because that's how fast he can design a page, plus the 8 hours it takes to learn the software. Make sense? Okay, so we need to get all the p's onto one side. So I subtracted 1.25p to get 0.25p equals 8, and then I divided both sides by 0.25. So that gives me 32. Make sense? Okay. So I want you guys to attempt problem 2 on your own. That's on page 22. You can work with the people around you. An office manager spent $650 on a new energy-saving copier that will reduce the monthly electric bill for the office from $1,200 a month to $88, or not $1,200, $112 to $88, and that's per month. After how many months will the copier pay for itself? So what are we solving for? M. Let's call M the number of months. Okay. So how much were they paying before getting the new copier? 112 per month, right? So 112 M, right? Because it's not for the whole year, that's per month. So you just multiply by how many months there are. Equals, what is the new bill going to be? $88 a month, so 88M. However, we have an upfront cost of the new copier, so what did you do? Okay, so that should have been your equation. All right, if this was as far as you got, that's okay. We should be able to continue going. What would you do next? Who's 7? Anthony, what would you do next?
You would subtract 88
Perfect.
by 112.
So you subtract 88M from both sides. And 112 minus 88, guys, what's that give you? 24M equals 650. And then what would you do? Who's 22? No, Pecan, then what would you do? Perfect. Now this one came out to a decimal. What'd you guys get?
27.777.
27.7777? That's not right. It should be 0 something. It should 27.083. Okay, so here's the question. Do we round it up to 28 or do we round it down to 27? Technically, hold on. Technically, the entire 27th month is already passed, right? So when we're at the 0.083, that's already into the 28th month, correct?
Yeah.
However, 0.08 of a month, that's like a day, maybe 2 days. And it's 8/10 of a month, so 8/100 of a month, 8/100 of a month, it's like a day, less than a day. So technically we could say about 27 months. Okay? If this number was any bigger, I would say you have to round up to 28, but we're practically at 27. It's like less than a day over the 27th month. Yeah. So this one, it would be appropriate to round down. If you did round it up, I probably would not mark it wrong. I would still give it to you because you are thinking correctly. We're actually into the 28th month. So how many years is that, guys? It's over 2 years. 2 years and 3 months. So it takes 2 years and 3 months for them to start earning money.
It could break by then.
It could break by then. What if they're making, though, like hundreds and hundreds of copies a day? Then probably. If they're not using it that much, it might not necessarily be worth it. Yeah. But that's kind of the thought process you need to be going when you're doing word problems. Does my answer make sense? How do I need to round it? And if it was you, would it make sense to switch to the new copier? Okay? All right, so back to your notebooks, example 3. We're actually almost done, so if you have extra space and you want to give yourself some extra space, that's fine. 2 times, in parentheses, 5x minus 1 equals 3, in parentheses, x plus 11. Okay, so what do you guys see that we could do first? Yes, guess what? That's what you do. So distribute the 2 into the parentheses that it's attached to, and distribute the 3 into the parentheses that it's attached to. So 2 times 5x gives me 10x. 2 times negative 1 gives me minus 2, equals 3x plus 33. Now this looks like the problem we did the very first one, right? Okay, so we need to get all the x's onto one side, so let's move the x's first. 10x is bigger than 3x, so I'm going to subtract 3x from both sides. Remember, that rule only applies to the x's, so it's just the x's that you're moving the smaller one. So what does that give you? 7x minus 2 equals 33. And then what would you do? Add 2. So 7x equals 35. Divide by 7. So x equals 5. So I am warning you ahead of time in your homework. It's very possible that some of these come out to fractions, okay? So it's very possible that it will happen. So don't freak out if it does. So example 4, part A. 10x plus 12 equals 2 times 5x plus 6. This is similar to the one we just did. Okay, so 10x plus 12 equals 2 times 5x plus 6. What would you guys do first? Distribute the 2. Okay, so let's do that. And that gives me 10x plus 12 equals 2 times 5x is 10x. 2 times 6 is 12. Okay. Oh my gosh. What happened? 10x plus 12 equals 10x plus 12. Is that a true statement?
Yeah.
You can stop here. No. No. And well, x can equal 0. X can equal 1. X can equal anything. So we say that we have infinitely. Infinitely many solutions. No, because we're saying that anything can be a solution. So there is an abbreviation for this. You can use the abbreviation, which is the infinity sign, which is a sideways H. And then I usually put many solutions. So that means that any number in the world, real numbers and not real numbers, fractions and decimals, negatives and positives, any number that exists will give you a true statement. Okay, so that's why we say infinitely many solutions. You can plug anything in for x and it will always work out. Okay, so when this happens, when you get an equation that is equal to itself, we call that an identity. So let's add that to our vocabulary. Okay. So on our vocabulary page, under like terms, let's add the term identity. An identity is an equation that is true for every possible An identity is an equation that is true for every possible value of the variable. Okay. I want you to come up with your own example. So the example that we just did was 10x plus 12 equals 10x plus 12. Give me another example that you come up with on your own for the last box, for an identity. So I'm going to use x plus 1 equals x plus 1. You can do whichever one you want. It doesn't matter. So we have one more, part B of example 4. Part B. 9m minus 4 equals negative 3m plus 5 plus 12m. Okay, looking at the right-hand side, what do you guys notice?
Like terms.
We can combine like terms. So let's combine like terms first. 9m minus 4 on the left, we didn't do anything to that, equals negative 3m plus 12m gives me 9m plus 5.
But they're the same thing.
Are they? No. Let's subtract 9m. So I'm going to subtract 9m from the right, which means I'm going to subtract 9m from the left. And what happens? They all cancel. So we have no m's, right? So we are left with negative 4 equals what? 5. Is that true?
No.
No. So we say we have no solution. And you can abbreviate that by doing a circle with a slash through it. That's the abbreviation for no solution. So if all your variables cancel out and you get a true statement, that's infinitely many solutions. If all your variables cancel out but you end up with a false statement, no solution. So there's two special cases. Okay, so we still need to do the left-hand side of our notebook. So on the left-hand side for 1.3, if you guys notice in your textbook, okay, so I'm pulling out my textbook, where the unit all started on page 22, you'll notice there's a problem that says number 1 and number 2. I want you to do number 1 on the left side of your notebook. Okay, so I want you to do problem number 1. And then there's the word problem that we did, right? And then there's one that says problem number 3, correct?
Yeah.
You're also going to do problem number 3 on the left side. I want you to do problem number 5. Problem number 5 is on page 23. And then problem number 7. So on the left side for 1.3, from your section of the 1.3 in your book, you're going to do problems 1, 3, 5, and 7. Okay? So that's your practice in class to do by yourself. Sound good? Hold on.